Alright, so we'll revisit a couple things from 5.3 first, and then we'll transition into 5.4. Come on, projector. So let's start with evaluating the sine of 60 degrees. So why don't you try that? Alright, who's got an answer for me? What do you think, Keegan? Square root of 3 over 2 is correct. Sine of 60 degrees. 60 degrees is triangle that looks like that. That means this one's 30. So across from 30 is 1. Hypotenuse is 2. The other side is the square root of 3, which is across from 60. Sine is opposite over hypotenuse. So opposite over hypotenuse, we get square root of 3 over 2. All right. How many got that right? See, you remember some stuff. How about the secant of 5 pi over 6? Try that one. All right, so the first thing you have to do is figure out what 5 pi over 6 is. That's how many degrees? 150. So we're looking for the secant of 150 degrees, which puts us in quadrant 2. This is 150 degrees, which means we have a 30-degree reference angle. So it's another 30, 60, 90. 1, 2, square root of 3. This one is negative because we're going left. That's positive because we're going up. So secant is the reciprocal of what? It's the reciprocal of cosine. Very good. So you could say that cosine of theta equals 1 over the secant of theta. Or secant theta equals 1 over cosine of theta. We're going to be using, that's called an identity. We'll be using that later on today in this lesson. So you did not need to write those out. I just wanted to make a point. So secant is, well, cosine is adjacent over hypotenuse, so this would be hypotenuse over adjacent. So it would be 2 over negative square root of 3, or negative 2 over square root of 3. The book would have negative 2 square root of 3 over 3. This, I guess, would be the book answer. Those are all equivalent answers. Yep.
Just because I can't remember the answer before, do we have to, for like quizzes and tests, do we have to put it in like for the book answer? So we have to put it negative 2 square root of 3 over 3.
I would give you credit right here,
Okay.
or there. If it was multiple choice, this would probably be the one that is there.
Okay.
Yeah, good question. All right. Number 3, let's find the tangent of pi. So this one's a little different. Anybody, raise your hand, I won't call on you, but how many think they got the right answer? All right, so less than we had before. The answer is 0. Yes, so a lot of you, the ones that had their hands up, you remember how to do it. So this is, it's a unit circle problem. We're not going to draw a triangle. Pi is 180 degrees. So 180 degrees is right over here. We're looking for the ordered pair that occurs at pi, which is 180 degrees. That's negative 1 comma 0. Okay, so then how do I, that's part of it. How do I figure out what the tangent is? Well, if I ask you the cosine of pi, what would that be? Anybody? Negative 1. Very good. Because cosine is the x value. What would the sine of pi be? 0. Okay? So cosine is x, sine is y. And why is that the case? If I have a point on the unit circle, I will call it x comma y. That means I went over x and I went up y. And it's on the unit circle. What's the radius of a unit circle?
1.
1. Very good. We'll use that again later on today. Radius is 1. So if I ask you what is the sine of theta, Sine of theta is opposite over hypotenuse, so it is y over 1, or just y. The cosine of theta is adjacent over hypotenuse, so that is x over 1, or just x. If I asked you the tangent of theta, what is that equal to? Y over x. Very good. Opposite over adjacent. Y over x. Another way we could write this is, if I know that y is sine theta and x is cosine theta, well then I can say that tangent of theta is sine of theta over cosine of theta, because y is sine, x is. So this is called an identity. This is actually the version that we will use more often moving forward, knowing that tangent of theta is sine of theta over cosine of theta. All right, so back to the question at hand. What is the tangent of pi? We can find it by just doing y over x. So 1, which is 0. All right, questions so far? Coming back to you? Kind of, sort of. Yeah, Keith.
Okay, and this is, okay, so when we have, like, so 150 degrees or 270 degrees or whichever number, how do we know which way?
So you know, good question. So if it's 150 degrees, you know that this is 90 degrees, that's 180, that's 270, that's 360. So 150 would be right here 30 degrees short of 180 degrees. I could ask you, what's the cosine of 3 pi? Anybody know what that is?
60?
Nope. It's negative 1. How'd you get that?
Go around the ones and then a half.
Good. Yeah, so 3 pi, if you wanted to convert it to degrees, it's 360 plus another 80. What's that, 540 maybe? Or just in terms of pi, 1 pi, 2 pi, 3 pi, we're right back where we were where tangent is pi, or tangent of pi. So the cosine of that point is negative 1. The sine of 3 pi would be 0. The tangent of 3 pi would be 0. So I would convert it to degrees, then it makes more sense for you. That's what I was saying. All right. Yep. What if I know that the sine of theta is equal to square root of 3 over 2? And theta is between 0 and 2 pi. Find theta. I think this will be the last 5.3 questions before we move on. So find theta. Okay. We start by figuring out what quadrants we are in. Sine is a positive number. What quadrants are we in? Where is sine positive?
1 and 2.
Good. It's 1 and 2. Sine is the y value. If I'm looking at the unit circle, y is positive up here, it's positive here, it's negative, negative. So like, if I was thinking about positive and negative, this, any order pair up here is going to be positive, comma, positive. Over here, it's going to be negative, comma, positive, a negative, comma, negative, and a positive, comma, negative. So where is the sine positive? The y value positive, it's right here, and right here in the top 2 quadrants. All right, so we have 2 triangles to figure out. Each of those triangles has a reference angle theta, and the sine of theta is square root of 3 over 2. So square root of 3 over 2. Opposite over hypotenuse. Opposite over hypotenuse. So we have this for an answer and this for an answer. How big are our angles? Well, how big is this theta?
60.
It's 60 degrees. How do you know it's 60? Yeah.
Because square root of 3 over 2, because you know that because the square root of 3 is across from 6.
Excellent. That's exactly what you should be thinking about. What's across from this angle? Square root of 3. So that means this is 60. This one would be 30 because that's got a 1 across from it. So our theta is 60 degrees. Now, the question asks theta between 0 and 2 pi. So that tells me right now our answer has to be in radians. So you'd convert that to radians, which is pi over 3. So there's one answer. Our other angle, starting from standard position right over to here, well, let's find our reference angle. How big is our reference angle over here? 60 degrees. Means this is 120 degrees, or 2 pi over 3. So both angles between 0 and 2 pi that have a sine equal to square root of 3 over 2, or pi over 3 and 2 pi over 3. Okay, there's a few of those questions in your assignment. I had a number of people in before school in here asking questions, so I would encourage you to keep coming in for help. Yeah, even if you came in for 10 minutes, it would have been a nice quick little review going into today. Questions on anything we did so far? In theory, you knew all that, but you've been off for a week and a half, 2 weeks. So, okay. So a couple types of questions that you'll see in 5.4. This is now 5.4 stuff. We're going to find a point, the point, on the unit circle at angle equal to, we'll say pi over 3. I'll use the same kind of spot as what we just did. So we're trying to find the point in the unit circle at theta equal to pi over 3. So this is our triangle that we already have drawn. I'm going to draw it again here. So pi over 3 is a 60 degree angle. This is square root of 3, this is 2, and this is 1. So this ordered pair right there is what? Can somebody tell me what that ordered pair is right there? 1 comma square root of 3. Very good. That ordered pair is 1 square root of 3 over 1 up square root of 3. Now, this question asks for it to be on the unit circle. Okay? This is not on the unit circle because it has a radius or hypotenuse of 2. The unit circle is half its size. So we want to know what's the point with this angle that's on the unit circle. It has a radius of 1. So how do I figure out how big this bottom is and this edge right here? How long do you think this one is going to be? 1/2. How did you get that?
It's half of 1.
Good. It's half of this size right here. So that's going to be 1/2. And this one will be half of this height, which is square root of 3 over 2. Okay? So all you need to do on a 30, 60, 90 triangle is draw it like you have been doing. But then you just take half of every side. And then we can answer our question. What is the point on the unit circle that corresponds to angle pi over 3? This would be 1/2 comma square root of 3 over 2. That's our answer. 1/2 comma square root of 3 over 2. Okay, this is less useful moving forward than what we were doing right here and doing right here. This is like answering one specific question. If it's on the unit circle, just take half of it. But what we had been doing, I think, is more useful moving forward. Let's try another one. So same question. So find the point on the unit circle at, I'll say, theta equals 7 pi over 6. find the point in the unit circle at 7 pi over 6. Draw the triangle, see if you can figure it out. Remember, the hypotenuse has to be 1. Alright, so I just noticed that this is the same problem that was in your notes. I would have rather done a different one. Sorry about that. So 7 pi over 6 is how many degrees? 210. Very good. So we've gone 180, plus we go another 30. Here's our triangle. That's a 30-degree reference angle. 1, 2, square root of 3. Negative, negative. Okay, so that's our triangle. Normally we would do it like that, but we need it to be on the unit circle. So this ordered pair here is negative square root of 3 comma negative 1. On the unit circle, we're going to divide by whatever the hypotenuse is. So it's negative square root of 3 over 2 comma negative 1/2. That's our answer. How many got that? Or at least understand it? Making sense. I know I didn't probably give you enough time. Alright, so both scenarios we were using 30, 60, 90 triangles. If we asked to find a point on the unit circle, let's say at 3 pi over 2, that's really helpful, because if it's a unit circle at 3 pi over 2, that's 270 degrees. Our ordered pair is 0 comma negative 1. We don't have to do any more than that, because that is the unit circle. So at 0 it would be 1 comma 0. At pi over 2 it would be 0 comma 1, and so on. What if we had one with a 45, 45, 90? I'm sure you're all thinking that. So let's find the point at 3 pi over 4. So find the point on the unit circle at 3 pi over 2 over 4. Alright, this one's a little different. How big is 3 pi over 4? How many degrees? 135. Everybody got that? You knew to do that first? Good. So 135 degrees is right there. 135 degrees. So my reference angle is how big? 45 degrees. Very good. So 45 degree reference angle, that means a 1, 1 square root of 2 typically. That's how we would do it. This one would be negative because we're going to the left. But on the unit circle, it has to have a radius of 1, so hypotenuse has to be 1. So what do I have to divide all three sides by? Good, square root of 2. You divide by the hypotenuse, because that has to be 1. So our little mini triangle is going to be 1. Square root of 2 is 1. 1 divided by square root of 2, and negative 1 divided by square root of 2. Now you may not see it that way. It's probably more square root of 2 over 2 and negative square root of 2 over 2. Those are the same thing. So what is the ordered pair? This ordered pair right there is negative square root of 2 over 2, comma, square root of 2 over 2. You could have also done negative 1 over square root of 2, comma, 1 over square root of 2. All right. Questions on those type of questions? That's one of the things that you'll do new in 5.4. I'm about to show you the next one. All right. So I talked about earlier where I said, well, we know that the tangent of theta is equal to sine over cosine theta. You know, on our unit circle, if that's true, then if the tangent is sine over cosine, then the cotangent of theta would just be the reciprocal of that, adjacent over hypotenuse, or over opposite. So it's just cosine of theta over sine of theta. So there's a couple of things. These are called identities. They're like building blocks in order to simplify expressions or perhaps solve equations or verify identities. We'll talk about what that is. But tangent is sine over cosine. That's very important. Cotangent is cosine over sine. I listed out the identities that you need to know right now. It's in your notes. There are a lot more of them. Bella, is there a pink sheet behind you on the shelf? You see a pink sheet?
Yeah, I see.
So hold that up. His name is Carl. It's a whole sheet full of trig identities. We'll go through pretty much all of those this year. This is all that we're talking about right now. So it's a fraction of what we'll end up using. These are probably the most important ones that we'll use. So this year and beyond, these are some trig identities that are going to be pretty essential. Okay, we talked about this earlier. Sine is equal to the reciprocal of cosecant. So sine is 1 over cosecant. Cosine is 1 over secant, and tangent is 1 over cotangent. These are the two that I just showed you. Tangent is sine over cosine, and cotangent is cosine over sine. Those are all ones that we've kind of been working with. There's 3 more down here called the Pythagorean identities. What's the Pythagorean theorem? You remember that? A squared plus b squared equals c squared. So it's not a coincidence that we've got something squared plus something squared equals something else. So these are all kind of, if I have cosine and sine squared, and that's 1, you could say that sine squared plus cosine squared equals 1 squared. That's a Pythagorean identity. There's 2 more. This is definitely the most common of those 3. So then you've got 1 plus tangent squared equals secant squared, and I've got 1 plus cotangent squared equals cosecant squared. Those are some of the identities. Now, what do we use them for? If you're going to simplify, this would be a perfect textbook question, it'd be a quiz question or test question. If you have sine x times secant x, and we're going to simplify that. There's one thing I would suggest. If you have a trig function up there that is not written in terms of sine and cosine, I would write everything in terms of sine and cosine. Okay, well sine x, you don't have to change it, so that's still sine x. But how can I write secant x in terms of either sine or cosine? 1 over cosine. Right? Secant is 1 over cosine. So this is 1 over cosine x. Okay, that's the first step. So if you've got like secants and cosecants and tangents, write everything in terms of sine and cosine. That's what I would suggest. Now, this is sine x times 1 over, so I'm going to put that over 1. We're going to multiply straight across, and I end up with sine x over cosine x. This goes on top, and the bottom is cosine x. What is sine x over cosine x? Tangent x. So we are done. How do I know it's completely simplified? You don't always know that it's simplified. But if it's just one trig function like that, it is completely simplified. But if it's a mixture of some and you're not quite sure, that is a good question that I really can't answer. You do as simplified as you can when you're simplifying. However, later on, you will be asked to verify. If you're asked to verify that the sine x times secant x is equal to the tangent x, all you're doing is making sure that one side of the equation is equal to the other side. Well, we could go through the same steps we just did right there, and we got tangent x. Is tangent x equal to tangent x? Yes, we're done. Verifying is easier because you know where you're going. You know when you're done. All you're doing is just making one side equal to the other side. Simplifying, you're not always sure that you're done. All right. Another example, if I have tangent of theta times cosecant of theta, and we're asked to simplify it. Well, we're going to write it in terms of sine and cosine. Tangent is sine over cosine. Cosecant is 1 over sine. And what do I notice? If I was going to simplify this, how could I simplify this? Very good. There's a sign on top and there's a sign on the bottom. They divide off to be 1, so I have 1 over cosine, which we know is secant theta. So it's simplified. So we're just using our identities analytically simplify whatever we have here. Okay, it gets more difficult. We're almost done here. If I have tangent squared x minus tangent squared x times the sine squared x, what is that? Okay, we're supposed to simplify this. We're actually going to factor it. What is common in each of those two terms? All right, so I'm going to write it a different way. What if you have x squared minus x squared y squared? What can I factor out of each term? X squared, right? I can take an x squared out of each. And if I take an x squared out, I'm left with 1 minus y squared. That's factoring using greatest common factor. What can I factor out of each of these? A tangent squared x. And I'd be left with 1 minus sine squared x. So the factoring that you have done before is going to get weird because we're going to be using trig functions with our factoring now. I factored out a tangent squared x. Now, anytime you see 1 plus something squared or 1 minus something squared, you should think of the Pythagorean identities. This has sine squared in it. Okay, so let's look. Cosine squared plus sine squared equals 1. Cosine squared plus sine squared equals 1. So I could subtract sine squared x. So cosine squared x is actually equal to 1 minus sine squared x. That's a thing. I just solved for, I moved sine squared over to the other side. So now I'm going to replace our 1 minus sine squared with a cosine squared x. All right, that was a huge step. Any suggestions on what I do now? I'm still working on this right here. That may or may not be completely simplified. Any ideas? What's the first thing I asked you you should do no matter what? What do we do up here? We write them in terms of what? Sine and cosine. Very good. So right here, tangent squared is sine squared over cosine squared. And we're still multiplying by a cosine squared. Now what? So we're left with, after all of that, this whole mess up here is really just sine squared x. Feeling good about that being completely simplified. Okay, I did not make it through all the examples. There's a couple more there, but I think that's enough for today. That is your 5.4 material that allows you enough information to get through the bulk of your assignment. I will go through examples that I can make up of this type or specific questions from your assignment tomorrow. We'll probably also do a warm-up with the unit circle type of question too.